going to do a problem involving Newton's laws. I have a big table here, 50 kilogram, could be a block or it could be a table or whatever. On top of that, I have a 10 kilogram mass connected with a string over a pulley to a 4 kilogram. Right now, assume that there's no friction on the top here and there's no friction over here at the front surface. Okay, so every surface is frictionless now. So the question is going to be, with what force should I push this 50 kilogram block so that the 10 and 4 kilogram accelerate with it and do not go down or up this way? Okay, so what should the acceleration and the force of the slide? Okay, so how do we analyze this? Well, here's what's happening. Let's draw the free body diagrams for everything. For the 50 kilogram, you have applying the force F. There is also a mutual force here happening. When you first begin accelerating this, the tendency of the 4 kilogram is to want to swing over this way, okay, to stay where it is, okay? But a 50 kilogram is not going to allow this to swing this way. It's going to exert a force. We can call that P. It's like an internal force between the two blocks. So in return, the 4 kilogram is going to push the 50 kilogram back this way. Action-reaction force, right? The 50 pushes the 4 forward, the 4 pushes the 50 back with a force P. So the forces on this are that, and then you have, of course, a normal force, and then you have its weight mg. This one doesn't really matter because there's no friction on the surface, so we're not going to need to know what the normal force is. So now I can say F minus P is equal to 50A. Okay? Now what are the forces on the 4 kilogram? On the 4 kilogram you have the forward force, P, okay, is equal to 4 times what? Well, you want the 4 kilogram to accelerate forward with an acceleration of A. Both of them, right? So the P is equal to 4A. Now, how about the vertical forces? Well, in the vertical direction, you have 4 times 9.8. That is its weight, right? 4 times 9.8. Then you have the tension T up. And then for this one, you have the tension T. You have, of course, its weight, 10 times 9.8. You have the normal force N prime. You have no friction here, so that's the only force. In the vertical direction, we don't have to worry about that because there's no friction here. So N prime is 10 times 9.8, which is 98. And then in the horizontal direction, that's the only force. So what's going to happen now? So in the horizontal direction, we're going to have T is equal to 10 times, and then you want the 10 kilogram to accelerate forward again with an acceleration of A. Therefore, if it accelerates forward with an acceleration of A, it will not slide relative to the 50 kilogram block, right? Or table. So if it accelerates forward at A, therefore, there's no relative acceleration. So we're going to say T is equal to 10A. So far, these are my equations. F minus P is equal to 58, P is equal to 4A. And then what? In the vertical direction, you don't want this to accelerate. You want it to stand still. So T is equal to 4 times 9.8. 4 times 9.8. Okay? Now, just due to these two equations, this is the horizontal equation of this. This is the vertical equation of this. We can substitute, it's the same T. So we can say this is 10A. A is equal to what? 4 divided by 10 times 9.8. So simply speaking, in order for these two blocks to not slide, the whole system needs to accelerate forward at a rate equal to the ratio of the two masses, this mass to that mass, times 9.8. So that's equal to what? 0.98 times 4. 3.92 meters per second squared. So the system needs to accelerate at that rate. If this was heavier, what would happen? 10 kilograms, 100 kilograms, 1,000 kilograms. So let's just say for the sake of argument, it was 1,000 kilogram. Then this would be 1,000 kilogram, right? And then 1,000 over 10 would be 100, right? 1,000 over 10 times 9.8. So that would be 980. Well, that's almost impossible to achieve. If this was 1,000 kilograms and that was 10 kilogram, I would have to exert so much force here, the whole system would have to accelerate forward at 980 meters per second squared. So that's almost impossible, right? Therefore, it will slide. It's hard to prevent it from sliding then. This makes sense. The heavier this is, the harder it is to achieve this. Okay? The heavier the top one is, the better it is, right? Okay, so now that we know what the acceleration needs to be, I could combine these two equations. F minus, substitute that, 4a is equal to 50a. F is equal to 54a. So therefore, the required force is what? It's the sum of this mass and this mass. So this and this times the acceleration. 54 times 3.92. Okay? Okay? So you need 211 newtons here in order for these two blocks to not slide. Of course, if this one was heavier, right? If it was 1,000 kilograms, what would happen? Well, then it would be 1,000 plus 50, 1,050 times the acceleration. So if this is heavier, it affects two things. If this is heavier, it affects the mass over here, which requires the acceleration, right? So if this is heavy, you need a faster acceleration in order for it to not slide. If it's also heavy, it increases this total mass. So this also becomes big. Therefore, it becomes very hard to make this achievable, okay? If this is heavy. Okay, now we can ask a variation of this question. We can say, what if the force is not equal to 211? What if it's less than 211? Or what if it's more than 211? What's going to happen? So if the force that you apply, let's say, is 150 Newton, or let's say the force you apply is 300 Newton, what is going to happen? Okay? Well, what's going to happen is this. What you can do, this equation still applies. F minus P is 50A, P is 4A, so F is equal to 54A, except here is what's different. Solving for the required force needed to have a certain acceleration. This time the force is given to us. So let's say it's 150. I put 150 here. That's equal to 54A. A comes out to equal what? 150 divided by 54. 2.777 with a bar over it, basically repeating sevens. So that means the whole system accelerates forward at 2.77. Now, will these blocks slide? The answer is right. Yes, right? In which direction will they slide? Well, since you're applying less force than needed, they will tend to slide forward, and this will tend to slide down. Okay? So let's solve for that acceleration. So the equation for this one, it will accelerate down with a certain acceleration we can call A prime. So it's going to be 4 times 9.8 is equal to 4A prime. So along the vertical direction, it is accelerating downward. In the horizontal direction, you still have P is equal to 4A. So this one is accelerating forward with the acceleration of A, which is 2.77. But in this case, we don't need to put that in here because we already figured out what the A will be. So we don't really even need to figure out what the P is in this case. Okay? So then for this block, though it is accelerating forward, t is equal to what? 10 times what is its acceleration? Okay, this is kind of the tricky part, because has two accelerations, this has also two accelerations, right? This one is accelerating forward at A, down at A prime. Okay, this one is accelerating forward at A, forward at A prime, A plus A prime. So it's actually accelerating with the sum of the two accelerations, right? So we have t is equal to 10 times A plus A prime. Okay? So we put the tension, 10 A plus A prime. Okay? So now we're going to combine this equation and this equation. So let me erase this one. The vertical equation for the 4 kilogram block and the horizontal equation for the 10 kilogram. We add these two, we get what? The t drops. 4 times 9.8 is equal to 4a prime plus, and then distribute this in, 10a, and then distribute the 10 into that, 10a prime. Okay? And then the 10a comes to this side, minus 10a is equal to 14a prime. Okay? 4 times 9.8 is the weight of this, minus this portion, 10a, which comes here, and then this is 14a prime. What are we solving for? The a prime. So 4 times 9.8 minus 10, the acceleration, 2.777, right? So 2.7 bar, 14a prime. So let's solve for a prime. Okay? So what ends up happening, since you don't apply the same force, it will accelerate forward 0.816 meter per second squared. This will accelerate downward, right? Now, if you exert a force of 300, what's going to happen? Well, you can go through it and you put here 300. What will happen? The acceleration will be double that, right? So if we go 2.77777 times 2, 5.555, 5.5555, repeating fives. The rest of everything goes the same way. And then basically here you put 5.5555, right? So now what's going to happen? The acceleration is going to be negative. The acceleration is now going to be double the amount. And the acceleration will be negative, but it's not going to be equal to the negative of this. So it's not necessarily negative 0.816. It is negative 1.168. So this goes back and this goes back. So that means I'm pushing this so hard that pretty much these two can't keep up with it, right? The inertia of the 10 kilogram block that wants to make it stay back here makes it go this way and this one go this way. So they basically accelerate up and this one accelerates to the left. And they cannot keep up with the acceleration of this one. Okay? Now we could add, if we want to, friction on the surface. We could add friction to this surface, we could add friction to this surface and analyze it. But it's not going to change the problem that much. Let's say we add friction to this surface. Then it might accelerate back, but with a less acceleration than if there was no friction. If I make this one 0.1, 0.1, let's see what we get. 4 times 9.8 plus 0.1 times 98 minus 10 times 5.5555555 divided by 14. Now the acceleration is negative 0.468 meters per second squared. Means it accelerates back with an acceleration of 0.468, which is less than the acceleration it would have had if it was friction, okay? So now you can add variety of stuff to this problem. You can add a coefficient of static friction, kinetic friction. You can make this friction, static friction, kinetic friction. You can add friction to this one, static friction, kinetic friction, and you can make the problem more difficult and develop it some more. But now you see the very basic gist of how to approach problems like this, okay? Thank you very much.